Welcome to this video about risk assessment, covering chapters 4 and 5 of the risk science book. The main focus is on the topics of chapter 4. A risk assessment aims at improving our understanding of the risks related to a system or an activity, and in this way support decision makers when deciding what actions to take. The key questions asked in risk assessments are: what can happen, typically go wrong, why and what are the consequences? And to answer these questions, the assessors use data, statistics, expert opinions, modeling and analysis. The bow tie illustrates these key features of a risk assessment. So a risk assessment is a process to identify risk events, sources, threats, hazards and opportunities, understanding how these can occur and what their consequences can be, representing and expressing uncertainties and risk, characterize the risk and determining the significance of the risk, and rank alternatives using relevant criteria. Using the terminology introduced in chapter 3, the events are referred to as A-marked, the consequences of these events C-marked, and the risk assessment develops a risk characterization: A-marked, C-marked, P, probability, qualitative, precise, imprecise, strength of knowledge judgments, and the knowledge, K. Consider the following example. Tommy is a graduate student. His professor has invited him to present a project to his class, professors and his department, and industry professionals. He is honored by the invitation but is nervous. To be prepared, he conducts a risk assessment for the presentation. His findings are shown in this table with the events A-marked, the severity of the events, likelihood judgments, strength of knowledge judgments, and comments and overall risk judgments. And if we consider, for example, number 5, the presentation is considered very boring, we see that the severity is considered moderate or high. It's rather likely that this happen. The knowledge strength is strong, and the overall risk is judged as moderate or high. For number 6, a professor is offended or provoked by what he is saying. Severity is considered as high, is unlikely, but weak knowledge strength. And the reason is that one of the professors is very sensitive to what is communicated, but it's not clear if this professor would actually attend this meeting. The analysis showed the key features of a risk assessment, commonly referred to as a course or preliminary risk assessment. Using this assessment, Tommy has an instrument for systematically studying measures that he could implement to reduce the risk, thereby giving him some control over these aspects. For example, he could simply accept the risk related to event 5, but he could also try to do something about it. Practice so much that he could talk without notes. Then this particular event would no longer pose a severe risk. However, this risk could affect some of the others. Presenting without notes could lead him to make him more nervous, thereby affecting event 1. For the event 6, Tommy made a simple event tree model. This type of tree is commonly used in risk assessment to analyze what can happen given the occurrence of an initiating event. Here that Tommy conducts his talk. Then 2 branches are introduced, responding to 2 questions. Depending on whether the answer is yes or no, 3 scenarios and consequences are derived. The worst case is that the sensitive professor attends the meeting and is provoked. If this professor attends the meeting but is not provoked, The consequences are not so serious for Tommy, but he would still perceive the situation as stressful because there is uncertainty whether this professor is provoked. Tommy uses this model to structure his thoughts in relation to this event. This was an example of a qualitative risk assessment. But risk assessment is also quantitative. And there are a lot of studies that are trying to quantify risk. And remember how we are describing risk by A marked, C marked, and probabilities, SOK, strength of knowledge, and the K. And very often the risk assessment is based on quantification of risk using probabilities and related metrics like FAR, fatal accident rate, TLL, potential loss of life, FN curves, and value at risk. And I refer to the book for more information about these metrics. Now, in order to derive at these metrics and these descriptions of risk, we often model the phenomena, the processes. Now, and that is what we're trying to do, is to link the events and the consequences, A and the C, A marked, C marked. And that we do with modeling of the phenomena, the processes. And we have looked into the event tree, there are fault trees, and there are so-called Bayesian networks, and other very complex models that are used in order to try to understand the system or the activity considered. And these models often include very detailed and complex computations of various phenomena. For example, if you're modeling a process plant, it could be detailed calculations of the of a fire scenario, explosion scenario, and so forth. But you don't see that in this characterization of risk. It's kind of underlying descriptions of the phenomena linking A marked and C marked that you are using in order to derive at these metrics, probabilities, and PLL, FN curves, and so forth. A risk assessment comprises two main parts: risk analysis and risk evaluation. So risk assessment is risk analysis plus risk evaluation. So far we have discussed the risk analysis part, which is concerned with understanding risk. It covers the identification of risk events, risk sources, threats, hazards, opportunities, understanding how these can occur and what their consequences can be, representing and expressing uncertainties and risk, and characterizing risk. Note that the term risk analysis is also used in a broader sense as the totality of risk assessment, risk characterization, risk communication, risk management, risk governance, and policy relating to risk. This broader definition goes back to the creation of the scientific journal Risk Analysis and the Society for Risk Analysis in 1980. It will be clear from the context what is the proper interpretation. Risk evaluation is concerned with determining the significance of the risk and rank alternatives with respect to specified criteria. The risk evaluation is conducted by the risk analyst, and in most cases they are not the decision makers. The decision makers need to see beyond the risk assessment to make their decisions. It is in general critical to separate what are the professional risk analyst risk evaluation and what are the decision makers' judgments and decisions. Think, for example, about a city which contracts a consultant to conduct a risk assessment for its many activities and functions. The analysts perform a risk evaluation to compare the risk levels in this city with other cities and what is generally considered to be high or low levels for the type of risk considered. The analysts do not, however, conclude what is acceptable or not acceptable risk. That is for the bureaucrats and politicians to decide. Thus, there is a leap from the risk assessment to the decision. This leap we refer to as management review and judgment, and is defined as the process of summarizing, interpreting, and deliberating over the results of risk assessment and other assessments, as well as other relevant issues not covered by the assessments, in order to make a decision. The management review and judgment is needed as the risk assessment has limitations in capturing all aspects of risk, and there are other aspects than risk that are important for the decision making. This figure shows the main stages of a risk assessment, covering the planning of the risk assessment, determining the context, the risk analysis and risk evaluation, and the use of the risk assessment. The planning covers the following elements: problem issue definition, clarify who are the stakeholders, set study objectives, establishing relevant principles and approach, and data and information gathering. The data and information gathering will also be a part of the risk analysis, which covers the following elements: identifying events, hazard, threats, opportunities, cause analysis, consequence analysis, risk characterization, studying and comparing alternatives and measures with respect to risk, and the risk evaluation, judging the significance of the risks and ranking alternatives and measures with respect to risk. This is performed by the risk analyst. And the use of risk assessment in cost-benefit type of analysis and other type of studies, management review and judgment, and the decision. Quality of risk assessments. What is a high-quality risk assessment? Is it sufficient to say that the quality of the assessment is high if the decision maker and user of the risk assessment are pleased with the results and the analysis conducted? Is the quality of the assessment mainly determined by its ability to satisfy the decision maker's expectations? No, as decision makers can be happy about some guidance which is based on poor risk science. High quality risk assessment means risk assessment according to risk science, the best knowledge available from the risk field. Can a risk assessment have high quality if the supporting knowledge is poor? Yes, sometimes we have to conduct risk assessment on the basis of a rather weak knowledge base. A decision is required now. We are faced with an immediate threat, for example. The risk assessment can improve our understanding of the risk and in this way support decision making. If the criterion would have been accurate prediction of the consequences, the risk assessment would then not be high quality. Such a criterion can be a goal in some cases, data-driven cases, low-level uncertainties, but would not work in general. The risk analysts need to base the assessment on some knowledge, but also assess this knowledge. Can it be strengthened? Are there some knowledge holes to be filled? The assessment could cover activities to enhance the knowledge, for example through research projects, but in general, there will be limitations on what type of knowledge generation that can be made within a specific risk assessment scope. What is a scenario analysis? Some people think it's a risk assessment. Others say it's not a risk assessment, it's something completely different. That we will look into now. Scenario analysis is a study of possible future states and development paths of the activity considered. The IPCC, in the Governmental Panel on Climate Change, refers in their assessment of the climate change to several scenarios with different levels of temperature increase. In January 2022, the Norwegian Institute of Public Health, FOI, referred to 4 scenarios describing potential numbers of COVID-19 hospitalizations in coming months due to the Omicron variant. It turned out that they all were too pessimistic. The newspapers confronted the Institute with this fact. Their response was that the scenarios were based on model assumptions, and these assumptions turned out to be wrong. A key assumption made was that the Omicron had as serious consequences as the Delta variant. However, this was surely a highly controversial assumption, as there were considerable evidence from South Africa indicating that Omicron was less severe than Delta. Should not that be addressed in some way? Should not the risk related to the assumption be reported along the scenarios? The example clearly shows that the scenario analysis is not a risk assessment. The scenario analysis describes a set of scenarios, say 4, and study the effects of these scenarios. Using the risk terminology, the scenario analysis describes a set, A1, C1, specific event and consequence outcome, A2, C2, A3, C3, A4, C4, but nothing is said about likelihood and knowledge strength related to these scenarios. Following a risk assessment, we should add probability judgments, SOK, knowledge strength judgments, and K, which will provide a much more informative categorization than just scenarios. In this case, scenarios should have been considered also reflecting that Omicron caused less severe consequences than Delta, and discussions of likelihood and knowledge should have been included in a systematic way to adequately communicate the risks.